You can access the things that you cannot really access in public clouds through Cloud Web. You can also you can do you know you can create a network experiment. The if the limited offering is available from the public cloud, however, it's very much expensive, right? So at a zero cost, you have more bare metal level access, not just virtual machine, but network with the whatever arbitrary topologies. Maybe I will go without them. Any questions?
Like, I have a question. In the quiz, we are confused about the cloud lab. What is the type of it? It said the
Deployment type.
yeah,
Yeah.
it said community, but we all, I think, I thought it's a public cloud because another statement I heard that
Public cloud, no, because public
it
cloud is whenever somebody pays, anyone could join.
okay.
Say you can only join because you are at UMKC and because I allowed you.
Yeah.
Right. So it's not for random people in the street.
Okay, got it. So it's a community cloud.
It is community cloud.
Okay, got it.
Good question. Anything else? Public cloud, anyone could access it, assuming they're paying, right? So some of you might want to use Cloud Lab for your project. So that's why I'm adding this earlier. And there will be an assignment. But if we have too many assignments, I might consider it as an extra credit, the assignment. We will see. I haven't decided on that. But maybe we could have done some checking. At least, I want everybody to play with it to some degree, right? So, yeah, we could have done it in class too. But I was worried that maybe Cloud Lab resource might not be available, so it's not your fault, but could be a resource issue. Anything else you recall from last time, Cloud Lab? So, as I said, you could use that as a platform for your binary term project, and binary project information is available, right? So, did you guys sign up? It's due May 23rd. I will be not available next week. So if you have any logistical questions, you better ask me today, now.
So what kind of, like, we already form a team.
So did you sign up yourself?
No.
So let me show you briefly. I want to make sure you can do How come you don't see my screen over here? Okay, so let's see. I don't see anyone signed up yet. Okay, so I want to make sure that this is working. Can at least the people you're here, even if you don't have everyone in the team here yet, can you just go ahead signing up yourself and let other students join your team if
Groups,
that's the case? Yeah.
class project. Huh? No. We thought we are in a
So
group
I will
now.
let you guys,
You,
everyone
me.
sign up for a new group, and then later I can move
Right.
some of the names once you do that. I want to just make sure that you guys can do it. Yeah. Are you able to create a new group? Let me know. I want to see 2, 4, 6, 8, 9 students. By the way, in the morning class, from hearing from my TA, not many students started in the beginning, later joined more. But when I look at the quiz, practically everyone has done the quiz. I'm concerned that somebody might be sharing the code. Never ever do that, first of all, right? The student will be in big trouble when they cut, and I have a ways to investigate, like looking at the times and such.
It has abbreviations. Yeah.
So let me know any of you have
GNU.
this is a science project group. You don't see that?
SOL.
How about the first group? Did you see that? So this is a final project group.
Okay, let's.
So some students have done over here. I have done actually first the accountability group. It's actually I see that it is gone. I don't know how why. This I see students are doing more than 4. This should not be allowed.
First created. You can see. Yeah.
Okay, looks like something that I will work with my TA. Okay, so to get things done. You should have let me know what you are seeing in okay. So we'll talk. I will talk with TA and make sure we get this done properly. So
Oh.
you know that there is a final project planning submission.
Okay.
Right?
That.
Did you guys see the final project planning submission?
Yeah.
So
I think
that is due 25th. I think it's the beginning of the next week. I didn't want it to.
I'll leave.
Cheyenne, what was the issue?
So I didn't know Ankita added me, so I created another group. So we are trying to dismantle that group.
That was class group, that is the wrong one.
Huh?
Oh, so that was the first accountability. But I had actually first accountability group
Okay.
automatically done.
We can join.
Okay. But it looks like it didn't work. So what? Let me show you. Oh, I don't want to create a group now, but I said after 4. Do you see the accountability group 2? looks like there might be, you only see these ones. You don't see the accountability. Okay, so I will check with I don't have a full view. What I don't know exactly what you might see. Okay, so know that the project plan, final project planning is due 25th. You have to, there are a number of requirements, you know, you have done. It is okay for you to change a little bit after your submission. So don't worry that if you feel not completely confident about project planning at the moment, but the point is that I want you to get started. I want you to get thinking, started, and start doing something during the spring break, right? So that's the idea. And then next Tuesday, I'm gonna have you guys to do a recorded lecture. It was about the open source licensing, and there will be a quiz for that as well. And then next Thursday, there will be an exam. You know the drill. During the exam, we are not supposed to leave until the class time ends. There was a student sometimes who finished the assignment outside of the classroom. That happened. All kinds of things. So the the strict measurement that I'm taking, there are reasons. So I hope you would understand. Okay. Any questions? So today is the last class in person before your exam too. What's that? Oh, the scope of the exam will be up to the topic that we discuss next Tuesday. So next Tuesday, recorded lecture on open source licensing is also included. You know, there are multiple open source licenses, not just a free software, and then there are different the connotations, recommendations, and requirements, and that's I want you to know about that. So after the first exam, from container, let me put it on in the announcement. Okay, so from container and then serverless, right? Edge computing. What's the next? We have storage. Yeah, all the storage. We are not finishing storage. Typically, I would like to, but this time we are not. We don't have enough time between exam 1 and exam 2. So storage aspect. Today we are going to talk about CDN. Next time we're going to talk about the storage services, and also Facebook storage to see how the things with what we learned in class they are applied in cloud services. So you'll see the rate and the novel rate, CDN, and novel ways they decided to architect their photo storage. Okay, so that's what we are going to talk about before we move on to networking topic and also the parallel computation development platforms. Okay, so today we're going to talk about CDN, that stands for Content Distribution Network Services. So this is a network used for content distribution. This has become an important, inevitable component of current largest system logic scale content services over the internet. So you can't really think of watching a Super Bowl game from anywhere in the continent, right? With that performance. Previously, it would hang, it's not the variable performance for watching the content. You can't think about Netflix watching movies with that quality without CDN. So this has become really, really important. The internet infrastructure now. So any example that you know about the CDN companies? The companies that provide the content delivery, distribution, content, the distribution network service. And we are in cloud computing class, and you know that Amazon provides that, right? CloudFront, we have talked about it before, right? Then what other companies you can think of? Azure, right? GCP. Google, right? Yeah, they are providing CDN services, but that's not they are not the pioneers of CDN. CDN was introduced a lot earlier, before the cloud has become popular. In fact, what do you think? In 1990s. So even if it started in 1990s, still to be this much prevalent for us to enjoy all of the streaming content with a high quality, it took a while. So it's not been that long ago. Even Netflix, I told you, they used to provide movie service with a DVD with a snail mail. So the internet service, it has some performance issues. Sometimes, still now, if you click on something, it may not work as well as you would want. It can take a while. It can be because the server is busy, or network path might have been congested, and some packet might got lost during the transmission. That means that you may have a glimpse in the received data. Sometimes browser can hang, and then user has to refresh it to get the data retransmitted. And sometimes there can be too much variations in terms of data delivery. So jitter means that inter-packet spacing. The first packet arrived after 1 second. Second packet arrived after 1 second. Then you are actually looking at the packets at a constant rate, right? But if there is a big jitter, in other words, inter-packet arrival time spacing is large, then sometimes you get a lot in bulk, and sometimes there might be amount of bulk of data not received for a while, right? So the bandwidth, the congestion, delay, and packet loss jitter, these are basically network performance parameters. If these are not good, then you have a problem in terms of content abstraction. There can be also, because of configuration issue, the link that you are trying to open may not be available, but it's not really, it's on the content itself side. But these are all the issues of network, right? By the way, jitter, there are there are techniques to overcome this. Server load, we want to have more servers so that the individual servers will have a lesser load, right? What can you do about path congestion? We want to control congestion control. What is the protocol that does congestion control? TCP. TCP does a lot of things: flow control, reliability, congestion control, connection management. So we do have the protocol that does congestion control, meaning that if the network path is heavily used, congested, then first of all, sender has to do something. It's not easy. The sender will have to detect congestion, and then in response to congestion, is it supposed to send at a higher rate or lower rate? What do you think? Lower rate, we have to reduce the sender's sending rate. How much lower? When you start to reduce the load, it's all part of network congestion control, and TCP does that congestion control. Packet loss. The packet loss happens due to the full buffer in a intermediate node, right? So the router will have a buffer for the handle congestions. Even if you cannot transmit the packet right away, it will put it in a buffer for a while so that you have a room, really buffering, right? And then they transmit it so that you don't have to drop it. However, buffer will have a limited size, and router buffer is expensive resource. So the packet arrives when router buffer is full, and the packet will be dropped, right? So the packet loss, the buffering can help to some degree. What can you do about jitter? Any technique you know? Typically, jitter is an issue for streaming applications. Jitter is not much of an issue for file delivery, file transfer. But for streaming application, big movie, you don't start watching a movie after entire file is received because it's too big. What we want is that the receiver side will start to play whatever received, and actually it will use some buffering to accommodate jitter. But if jitter is large, that means receiver buffer has to be big, right? And still, big one will have a limited size. So there can be an issue. But again, receiver buffering can do something about jitter. Packet loss, router buffer can do something about packet loss. Congestion, senders the protocol can detect and reduce the sending rate to do congestion control. Server load, we can have more than one server to handle the load. So there are a number of reasons why the performance might not be good, and by looking at what could be the issue, we also have a number of techniques to address those, right? But still, these are all limited, especially for the techniques that I have mentioned. It works to some degree, but actually, like 15 years ago or many years ago, people in industry started talking about prior to that, it used to be just some short web content, and VoIP, voice over IP, was a big thing. And then in the near future, video is gonna be the highest amount of traffic in the internet, and there is a big thing, and people will try to prepare what's coming ahead. And one of the main reasons of the video content in on the internet or in the network application is the big content, right? The content like Netflix movie, content like Netflix movie is a stored, already made content. The Chiefs game Super Bowl is live content that is being generated. And also there are some content like CNN. It's not necessarily large for all of those, but there are many pieces, and also the scope, geographic scope, the content has to reach is huge, is international, right? So there are more contents that are being generated. So we need to do something with the network. So this is some illustration. Suppose there is a source and a lot of customers are trying to receive the content. It will be over the network, that could be over multi-hub. So if we think about this path, right, what do you notice? From one source to multi clients, one server to multi clients, or one source to multiple, the consumers. You see that the same traffic is sent out in a duplicate manner, right? So that's a redundant traffic that are being sent out, and also this path might be less congested, but the other path, the more closer to the source, it's more redundancy, it's more likely to get congested. The origin server would be the bottleneck with the number of users. And then there has been, so of course people think about, this coming ahead at the prediction, we are doing it. However, there are some big social events that happens that gives a good real motivation. Maybe, the technology, the involvement, so many things that did happen, does happen, will happen due to notable social events. Okay, so there has been some so-called flash cloud. This is also a technical term. Flash cloud events, where so many users are trying to access online content at the same time. Previously, flash cloud event used to be some big content, used to be, what do you think? It's in the technical community, it was like Linux kernel distribution. Right? So that's a big content, and then a lot of people, tech-savvy people try to get it as soon as possible. Early adopters, you don't even think about that as a flash cloud now. But the really 911 event, Japanese earthquake, and then also more recently, Obamacare website, when it was first launched, it was highly anticipated, the new program, and people has to sign up for the healthcare, and then the website didn't hold up well. So they didn't, they only focused on the content, not really content distribution much. So after these things, the content distribution is more, the better prepared technically and also better utilized. And people who are doing the content, like Obamacare, or any government, or any significant, the commercial information, when they launch it, they think of this in advance now. So that's why you don't hear about this big, website hanging issue. Not much, at least in this country. Other places, still. So this is really about content distribution problem. This is a content distribution problem. How do we do that? Is that through a network and arrange several rendezvous points between content source at the origin server and content user. So rendezvous points meaning that, here's a source, here's a client, and somewhere in between, let's have a meeting point. In between, in fact, is closer to where users are, where the consumers are, meeting point, and then these end users can access the content through that rendezvous point, not all the way from the origin source. So that's basically the essence of the solution. So we try to address content distribution problem with a network, okay? And there are multiple networks that does this service. So CDN networks. It tries to address the problem how to stream the content, to send the content. Many users, big content at the same time. Okay, so that's the thing. So if you really just focus on this problem, what the I already said that the good solution is through a network. But before we think about it, what are the other options available? Right? Naive solution could be making this server to be super huge, make a single large mega server, right? Then we want to point out, this is not a good solution. Why? Because of these things. Single point of failure, it doesn't really address the congestion we have mentioned, right? The mega server, in fact, this one can be huge, but still this capacity should be big. Even if with this big capacity, you cannot really have enough capacity for all of the users in the world. What about the congestion on the path, right? And also, people from India, if we have a origin source in Kansas City, it's the other end of the globe. So, the longer the distance is, more likely you might run into congestion. And also, just there's the sheer amount of propagation delay. Once something happens, retransmission has to happen, TCP. Retransmission, again, it takes a long propagation delay, so performance will be really not good. When we talk about the communication propagation delay, these days making the biggest one, so it contributes the biggest. So, like from Earth to a satellite, long distance, the long RTT, round trip time, that makes the performance really poor. So the really portable has to be designed in a way that does not really have a lot of chatting interactions, right? But TCP is not really, it does involve multiple interactions, getting the feedback and then retransmission. In the protocol, chatting protocol, like, hi, shall we make a connection? Yes. Okay. Okay. Are you ready? Ready. Really ready? Ready. That doesn't really happen. It's usually three-way handshake. That's enough. But still, here's a packet, and then I get the acknowledgement. At least one round trip time, RTT, that's involved. So the longer propagation delay will make all this the protocol interaction takes long time and make it overall bandwidth slow. So this first naive option is not good.
Okay.
Doesn't scale. How else can you do?
Storage server
So
copied.
we want to promote the CDN, and this is a CDN time. I'm glorifying CDN today. We want to have a rendezvous point, and that rendezvous point will have the content copies, many different places geographically. The very first, so you talked about what are the companies? Of course, yeah, the AWS CloudFront, Azure, GCP, they have a CDN services too, but they are late, the late players. The practically pioneer of CDN is this company called, how do you read this company name? Akamai. Okay. So Akamai is the, like many things we talk about in class, started from academia, between MIT professor and his student. After having done a paper, they went on and they have this is a really nice idea. However, to make things working and then also in a larger scale, it takes a lot of business acumen and love along the way. So many things. But they actually made a big impact. My very first student, many years ago, 20 years ago, his first job was screens, but later he joined Akamai, and then he came to my class as the guest speaker. You might do that in the future as well. And talking about Akamai, we start with his company's promo info, right? The internet history. Internet history, Akamai is a big player in the internet history. The history is written or spoken by people who really write history, right? So I think that they do deserve a big credit in the current the quality of our internet life. So now it's so big one, and then these days there are so many the CDN companies. So if you just do a Google search, the CDN companies, there will be so many. Limelight is one of them. So the Akamai is the one that pushes CDN, their duplicate copy replica servers deep into many access network. So this is a before cloud. How do they do that? Idea is that having this server closer to the user. Akamai company, they will not bring a server, new Dell computer with a big storage in your village, in your home, near your home, right? Where do they bring these servers in? Before cloud company, they would put those things on the telco company's hub, point of presence, right?
Okay.
So you see so many examples where telco companies miss their opportunity. They could have done it, right? All the now cloud companies does cloud company, they have a data centers, but it's not the data center. It's a handful within a country. It's not like tens of thousands. There's so many. It's a lot less than the number of hubs with the presence in the continent run by telco companies, right? So they actually use telco companies' presence. Actually, any CDN companies will use that for their content distribution. And Limelight is another one. So CDN, the way it works is that suppose here's a home user, here's the Netflix origin source, and this user wants to, subscriber wants to have some content. So this slide is from network architecture textbook, top-down approach. In fact, he's my academic grandfather, who has written the most popular networking textbook. Anyway, the way it works is that there is some file or some information. Okay. So subscriber requests the content. I want to watch this movie. Then what source is sending? It's not the movie or content. It only returns so-called manifest file, and then this is a control information, not data information, that has a list of. This is really high level view. We're going to talk about a little more detail. This is the manifest file will include the potential servers nearby, and then the home user will choose and retrieve data from one of the servers nearby that will give a higher or highest bandwidth. Okay. Suppose while receiving this content, the network has had some problem, server might have a problem, then it can be adaptive, choosing a different server. So that's how CDN works in very high level picture. So it's not like I want this movie, here it is. It's not like that. The first control information is exchanged, and based on that, the control information is exchanged to the remote, potentially logically single, but practically it will be more than one. The remote origin server, but the actual data will be retrieved from one of the nearby content distribution servers. So going back to the content distribution problem, we want to do it through a network, but still we can implement it in a different ways. One way of doing it is a server farm. Basically, what it means is that rather than single server, let's have many by the same provider or content provider, right? I want to, the one single server is not enough. Let's have 10. Let's have, say, up to 100. It's a simple solution that can be made by whom? Content provider. Right? By the way, so far we have talked about the CDN company and CDN companies, right? And then we talked about the content provider, and then there are users. So user, content provider, and CDN provider, they are all different, right? This one, server farm solution, is something that could be done by content provider, not through a third-party content distribution network provider. So I'm talking about this content network type having more than one to address the scalability issue of content distribution. I want you to pay attention to who does that, right? So server farm by content provider. What about the caching proxy? This is also one way of getting the content distributed to many users in a more scalable way. So what is the caching solution? That is done by users ISP. So you are in UMKC network, or at home you might be in Comcast network, right? Whatever you as a end user have your access network ISP, and that access network ISP, knowing that there are a lot of users in my network who are accessing the same content, I better have the copy locally, so that my customer, as an ISP, my customer will be happy. Okay, so that's a solution called caching proxy. So that's not a real server, it's a proxy server, fake server that can distribute the content. Again, this is from ISP. This is from the content provider. This is from the third party, but this is actually through ISP. But the other one is using Akamai style, the third party CDN focused company. This is really by this company. The service is provided by the CDN company. This company's customer is what? Content provider is a customer. So the CNN would be the customer of Akamai. Okay. Originally, it was optimized for smaller object, 10 KB. What does that mean? Not like movies. So it is almost for like CNN.com, not necessarily big for all of the individual content. And whole file caching, not a streaming originally. Nowadays they do streaming too. The whole file will be copied, cached on their CDN servers, and it has now evolved with a dynamic adaptation too. So these are some ways of doing content distribution through a network. Another idea you could have said is that P2P network. So this is really peer-to-peer network. There is no responsible server that has to be online all the time and serving customers. This just use their own software protocol um, and individual peers storage. Okay, you don't have a real guarantee of performance. The and depending on the protocol, their performance can be very different. In network architecture class, we talk about different generations of P2P, right? The centralized directory service, Napster-like, and then completely distributed Nutella-like P2P, and then there is BitTorrent-like P2P, the third generation, the one that we use most, and the one actually they're used by all the idea. It's not really by regular students or people's computer, but still the idea of peer-to-peer and technology of the peer-to-peer network, it is used these days in most of the larger scale services, internet services, including Skype. So let's look into that a little more detail. The server farm is where the deployed by content provider, right? Group of servers, replica 1, 2, 3. Then your question is that suppose Toxis used to be our cluster, SCE, now the SSC, right? So multiple users are making the same request to the CNN.com. Suppose the server farm is, in this case, there's 3 copies, okay, 3 servers. Then the question is that even if there are 3 servers, if all the requests from different users go to one server, then it's no use. Then the question is how to distribute the load among the servers, right? What do you think? How can it be done? At the high level, it's easy to have more than one server, but how can you ensure that those multiple servers would share the load? Users will use the same URL, www.cnn.com. How can you ensure the request will go to different servers so that the load would be distributed?
Different.
Yeah, load balancing. So how can the load balancing be happening? That's what we want to do. So
Different IP address.
They will have a different IP address, right?
Yeah. So.
But they have a same.
Yes.
www.cnn.com.
Yes, but different IP address will create to allocate to send the different location.
So all of them will have a different IP address connected to the network, right? But their URL will be the same.
Yes.
Users will not click on different IP address.
No, it will be linked with the IP address.
Yeah, so the question exactly that should happen when user type in www.cnn.com, different IP address should be resolved. They should be connected. I mean, they should be matched to the user, right?
Yes.
Who does that translation between URL, domain name to IP address?
Server farm.
What kind of server does it? When you type, I mean, what is it called? Domain name to IP address resolution. That's called DNS, right?
DNS.
So
yeah.
DNS server has to do that. to distribution. Load balancing, how can it be done? There can be many ways. Underneath, there should be DNS. DNS plays an important role. We'll talk about it a little more later, even with the CDN too. So then you should ask question, DNS, who's DNS? It's a CNN.com name server, right? But how the CDN name server or CDN plays in, that's you pay attention to. Proxy, caching proxy is again deployed by whom? Access network ISP. So here are clients, multiple clients, and trying to access the same content. Rather than these contents go all the way to the origin server across the internet, if it finds that it's a certain destination, it will be intercepted, and this proxy server, which is a part of the ISP, will, if the first one already got it, content is cached, stored already, then the second client, when makes a request, it will be intercepted, and the data will be retrieved from this proxy server, fake server, not from the origin server. Okay? So the way, how it is done? First of all, it is done by ISP. Your ISP should have this proxy server. Why do they bother to do that? Because they want their customers happy. UMKC, IT want you guys happy and the network performance. And proxy, caching proxy can be one way to improve the performance, and also it reduces the traffic across the internet. How it is done? When you configure under your network, what do? You need to have an IP address. You need to have a local DNS server and the default gateway router, and also cache proxy server needs to be set up on your browser so that your traffic may not go all the way to the origin server and be able to exploit the existence of caching proxy. You can actually decide not to use it. You want to always get the data from the origin server, that's fine as well. So it's again motivated by ISP business interests, making their customers happy and also reduce their the traffic across the internet, this is more expensive link. This is a local link, less expensive, right? Then user will be seemingly happy because, oh, I got this right away. User perceived the latency is small. CDN is, as said before, there's an origin server, a lot of users might be over here. They copy this content. I have mentioned the idea that, okay, the popular content or content provider might ask this content to be distributed in many different places where the users might be in, but you know that it will not be done manually, right? So there should be their protocol strategies, policies for this distribution. We also have done research, which content has to be pulled or push it, what are the trade-offs. So there are a lot of secret sauce algorithms behind it. The basic idea is that closer to the users, lower tier ISP, access network ISP, that's where the CDN company might want to have copies of their content, not their content, their customers' content. But there might be some updates on the content, especially news, maybe not movie much. The news and on even website too. So then this update has to be also controlled, and that's also task of CDN provider. So to promote, to glorify CDN, we want to talk about the problems with the server front and caching proxy again. Server front, it's really about making server large, but we talked about the problem, not only server load, but also path congestion, all those, latency. The server front does not address any of other those things except the server load. Cache proxy, this is good to have for clients in their network, but this is done by ISP, Internet Service Providers. Not every ISP may have it, right? So from the provider's perspective, we have to make sure that user will have a good performance. They don't have a control on that, right? So there is no business guarantee they can make as a content provider. And also caching proxy, their update policy. Of course, user can do something, the refresh. However, content provider want to make sure that whenever they first click, the users they get the most updated one, right? So the content provider really wanted users have a good the most updated content at a real time, and that's not what caching proxy can guarantee. And another problem, this is really important business problem, is that caching proxy, you cannot really, as a content provider, you cannot really see how many users are watching at this moment. YouTube, how many users are watching that they have it, or like some live event. You can't really make sure that one using caching proxy, right? It's all behind the caching, behind the ISP. For CNN, they want to know how many users have watched this content. They want to know which one is popular or not. It can be also used for advertisement. So many business aspects. How many users are watching from which location is all important, and caching proxy cannot really provide that. So this is a picture from Akamai. That shows the Akamai idea. The paper was a lot earlier, but here's the idea. Origin server, replicated web server, not just one cluster. So it's not like every 100 meter, every 1 kilometer, there will be server in the middle of cornfield, right? There will be the server that needs the heating and cooling, the energy, and that will be co-located usually with the ISP's point of presence, where the routers and switches are interconnected and hosted. So the CDN companies also will have the cluster of servers in that location, not just single server putting there. Replicated web server cluster, replicated cluster, replicated cluster. So that's what we have. Origin server, has a network with the replicated servers, and users will actually get the content through one of the replicated servers. As said before, first CDN started in late 90s by Akamai. I really hope you would be able to appreciate their work, right? In late 90s, before they had all this, big abundant amount of content generated, used, they had this thought. Really, no matter how, at that time, most of people, what they thought is that, we need to have a higher bandwidth link. We need to have a higher powerful server. But they have thought that this is not going to work. We do need to beat all the propagation delay and all the congestion issues. Whatever protocol, people were actually doing congestion control protocol at that, back at the time, but this is not going to work. And then they have this idea of CDN, have the server have a copy of the content, And then how to do it? Of course, there are a lot of protocols. The algorithms they suggested for that goal, but having the big idea, that was really amazing. And then, mirroring image. The originally it was U.S. only, still, but it was really big in U.S. And then some social events happens, flash crowd, then people in business, CEOs, not CTOs, CEOs can really see, oh, this is what we do need to have a technical solution to address this issue, and there is a document there. Let's use it. Large scale ISP AT&T. They actually tried a little bit. It's not that they think about it at all, but they didn't really succeed. I think I showed you a picture before, the history of computing, right? There is the ISP, and there was a server. Yeah, we have shown in this class. So the server hosting was one of the big moments. Server hosting could have been really exactly CDN. Could have been done by AT&T, T-Mobile, Sprint. They didn't do it. Now, so ones who, this is harder for us. You might think it's understand, but who does that work? Who has that the history, experience, and driving force to do that? That makes a really big difference. So the ISP to CDN didn't work well, and then CDN grew big and big, and it's just an inevitable part of the internet and cloud. This one I probably have to update it again even further, but Akamai, Limelight, Edge Test, and then there are, if you do the search, thousands of CDN, you will see Google, Facebook, Meta, AWS. So here you see cloud companies, some ISPs, and even other the big software as a service companies also they take part in this CDN. I mean, I should not say not software as a service, the content providers. Right? Facebook is a big content. Netflix, Facebook. Actually just talking about the Netflix, they were interested in the movie delivery. Started as a snail mail, the DVD, not CD. So they were good at that, and then they had decided, oh well, everybody has to use the online internet, so we have to do that. And their idea, they don't have a big infrastructure for this. I mean, even the internet performance was not as good in the beginning. So they started actually just use like what you would do when you try to start a business. Have this idea, some server, maybe server farm, a few more, but real data delivery would be through AWS. So there was earlier paper. So whenever there are new things appears, everybody actually was surprised. Wow, movie, we didn't think that this will perform this well. How did they do it? Okay, they are not really IT company. They are a movie distribution company, but behind it was AWS. And then you can think about the AWS, and I'm maybe talking about sites. So AWS using it is expensive, right? Other CDN is expensive. They also use that, maybe Akamai as well. I mean, it's expensive to do it. So what do they do? What do you think? Initial low barrier to entry to get into this cloud-based service, but it gets expensive. Then you do on their own, right? So Netflix, they do their own CDN. I think, yeah, later I might have I think I can, not entire lecture, just a little bit how they do CDN initially from other cloud providers, and then they decided to use their own. But it's not something like, oh, from now we're gonna use our own CDN. That's not how it's gonna happen, and the cost difference will be very much. So they actually do it gradually, and we'll see how they have done those. I said that this will be the last class before the exam, so maybe I will go a little earlier. So the customer is a content provider. Benefit, removing redundancy, reducing server load. This is all very important, right? User perceived latency will be reduced. And because of this, internet congestion was a lot better controlled. Users, maybe now you know, but a lot of other users at home wouldn't know if CDN is used. They just know Netflix. They don't know CDN behind it. So the commercial CDNs are the one for real content delivery. So Akamai, public clouds, and content provider, they can also do the network. I think I have slide later. But another thing to point is that CDN, there can be academic CDN. In fact, actually, this is also big research. Akamai started with academic, and the peer-to-peer network, this the academic CDN, CDN, a lot of algorithms and strategies was produced, and it needs to be experimented. It needs to be shown. Its performance needs to be compared. We need big real test bed. So for that, there has been these kind of test bed: coding, Coral, CDN, Global. So Cloud Lab, its predecessor, or if it's still we use it, called Genie, Next Generation Internet Initiative. So there was a Genie. Prior to Genie, there was some academic network testbed experiment platform was called the Planet Lab, and that's all the network testbed. But using this, we can do a lot of study, not just a new protocol design experiment, but we can also do CDN. So on the coding Coral CDN Global were the CDNs that were deployed on Planet Lab. If you go to Cloud Lab, it says native Emul Lab, right? So Emul Lab was part of that Planet Lab, a lot of those lab names. And then in the network, you could access these one too. So as a researcher, as a student, I want to do something new. There are people, most likely other people in the research community have thought about it, and we need to, and the National Science Foundation of U.S. Actually supported a lot of universities to do such research, and part of those research will be developing a test bed. Let me actually go to take a look all of these. We talk about this commercial public cloud as well. CDN components, origin server. There's another name called the surrogate server. Proxy server is the name used by ISP. It's a similar thing, fake server or not a real server. But surrogate server is the name it's used for CDN. Okay, these are the copies. And then there's a content router, accounting mechanism, and network elements. That's where secret sauce is. I think you can probably take a look. Let's see. So origin server, surrogate server will be closer to the clients. CDN is an overlay. So this is a network, overlay network. Underlay network will be on just ISP. overlay network does not include IP, Ethernet. It's the above layer, application layer network. There are infrastructure for this CDN, distribution and accounting, and request routing. So clients will do a request route, the request infrastructure, and actual data will come from surrogate server. Some surrogate server may not have the content the client is looking for. Then the request routing infrastructure will have an interaction with the origin server. Hey, this movie is really popular in this area. We need to have a surrogate server have a content on that content in this server. So that will, that distribution will happen. So these are the infrastructures. Even though I didn't have a time to explain much, it will be part of the exam because that's a real how the technology works, right? So let me just tell you this one origin. So this user will client with a number of servers. First of all, origin server, hey, foo.com or CNN.com, you type in and the name resolution. Yes. 11:30. Okay. You can leave. Good luck. Yeah.
But we can see a quiz.
Oh yeah, I need to give you the quiz code. I will actually remove the quiz code for today, right? And you can take the quiz by tonight. It will be open by tonight. Yeah.
By tonight, not today. Today we
It
need.
will be open today. It will be due by midnight.
Okay.
Yeah. So this DNS name resolution, that's one I want you to really know. It will be part of the exam. Please take a look at all of these slides. Oh, maybe I will add some recording, but I'm not sure if I will have time for that. I will add some